You are welcome back to this channel. So in today's class, we want to use matrix method to solve simultaneous equations involving three unknowns. You know, I told you that you can use simultaneous method to solve it. You can use determinant method, which we know as Cramer's rule or so. So now we did for two unknowns. So today we want to do for three unknowns. So follow me. Now, the first thing is that we have to write it in a matrix form. Write in a matrix form. So, coefficients of all these unknowns, we are going to arrange them in a rectangular pattern. So, we have 1, 2, 1, 3, minus 4, minus 2, 5, 3, and 5. Then all those unknowns, x, y, z, is equal to 4, 2, minus 1. So after arranging it in a matrix form, so we now say that let A be equal to 1, 2, 1, 3, minus 4, minus 2, 5, 3, 5, and let x be equal to x, y, z, and b for any alphabet b 4, 2, minus 1. So let's name this one equation 1. So it means that our matrix 1 becomes, let's check together, it becomes what? You can see that this one has become A, this is our X, and this is our B. So we can easily say that this is A, X is equal to B. So name that one equation 2. So having done this, but what we are interested is this x. You just want to know the value of this x, y, z. That means I need to isolate x. So I want to make x the subject of the formula now. So how do I do that? I can only do that by multiplying both sides of this equation 2 by inverse of a. So multiplying both sides of equation 2 by A inverse gives, so if I multiply both sides by inverse of A, I have A inverse multiplied by A, x is equal to A inverse multiplied by B. Let me call this one equation 3. So from here, you have to recall that if you multiply any matrix by its inverse, you are going to get an identity matrix. Identity matrix. So that means this equation 3 becomes I multiplied by x is equal to A inverse multiplied by B. Equation 4. You need to still recall that if you multiply an identity matrix by any matrix, you are going to get that matrix back. So this equation 4 becomes x is equal to A inverse B. So can you see now? So this one, let's call it equation 5. So the next thing that we need to find is the inverse of A. We know A, so we need to find inverse of A. So to find inverse of A, the first thing that you have to do is to find the determinant of A. Finding the determinant of A will tell you whether that particular matrix has an inverse or not. So if the determinant of A or that matrix is not equal to 0, that means it has an inverse. So let's check. So determinant of A of 3 by 3 will be 1, 2, Now, the first row of this one, so let's put the signs. So I have plus, I have minus, I have plus. So what do I do now? What I'm going to do now is that the determinant of A will be equal to, I'll write plus 1, then I'll cover that one horizontally, I'll cover where it belongs vertically. So I have left, so I need to find the determinant of the remaining elements, and they have minus 4, minus 2, 3, 5. Now come here, so I have minus 2, so write that minus 2. So you are going to find the determinants of its remaining elements here also. So you cover where this minus 2 belongs horizontally. So you are going to cover where it belongs vertically. So you are left with 3, you are left with minus 2, you are left with 5, you are left with 5. I hope you are getting it. So the next thing that we are going to do now is to go to this plus 1. So plus 1, so multiply by the determinant. So cover where it belongs horizontally, cover where it belongs vertically. So you are left with 3, minus 4, 5, and 3. So determinant of A will now be equal to 1. So let's find the determinant of this 2 by 2. Minus 4 multiplied by 5, that's minus 20. So minus 20 minus 3 multiplied by minus 2, that is minus 6. So I have minus 6 here. Minus 6. So now I have minus 2 here. So 3 multiplied by 5, 15, minus 5 multiplied by minus 2, that is minus 10. Then plus 1, 3 multiplied by 3, that is 9, minus 5 multiplied by minus 4, that is minus 20. So now, my determinant of A will now be equal to 1 multiplied by minus 20 plus 6. Minus times minus 6 gives me plus 6. So I have minus 2 into bracket 15. Minus times minus 10 gives me plus 10. Then plus 1 into bracket 9. Minus times minus 20 gives me plus 20. So, determinant of A is equal to 1 minus 20 plus 6 minus 14. Minus 14 minus 2, 15 plus 10, 25. Then plus 1 multiplied by 9 plus 20, 29. So our determinant of A will now be equal to 1 multiplied by plus 1 multiplied by minus 14 gives me minus 14. Minus 2 multiplied by 25 gives me minus 50. Plus 1 multiplied by plus 29 gives me plus 29. So here I have minus 14 minus 50, and that is minus 64. So I have minus 64 plus 29, and that is what? That is 35, minus 35. So the determinant of A here gives me minus 35. So since determinant of A is not equal to 0, that means A has an inverse. So having known that, we can now go ahead and find the inverse of this matrix A. And formula to find inverse of matrix A is A inverse is equal to 1 over determinant of A multiplied by adjoint of A. So we have known the determinant of A, so we need to find the adjoint of A. And to find the adjoint of A, we need to find cofactors of A. Let's represent the elements of cofactors of A by capital N. Each will be having all this subscription. So let's write it. Let's write this 1, 2, 1, 3, minus 4, minus 2, 5, 3, 5. Now, put sign on them. This is plus, minus, plus, minus, plus, minus, plus, minus, plus. So, we want to do for A11. So, we write plus there. So, you cover it here, then you cover it vertically. So, you are left with minus 4, minus 2, 3, and 5. So, A11 will now be equal to plus into brackets. We are finding the determinant of this 2 by 2. So, I have minus 4 multiplied by 20, minus 4 multiplied by 5, that is minus 20. So then minus 3 multiplied by minus 2, minus 6. So this gives plus into bracket minus 20 plus 6. And that is what? Plus multiplied by minus 14. And that is what? Minus 14. That is our first element of cofactor of A is minus 14. So here 1, 2, 3, 1, 2, 1, 3, minus 4, minus 2, 5, 3, 5. So here it has minus. That is A12. So it will be minus, then determinant of cover it horizontally, cover it vertically. So I'm left with 3, minus 2, 5, 5. And that will be what? Minus into brackets. We multiply 3 by 5, that's 15. Then minus 10. Minus 10. And that is what? Minus into brackets 15 plus 10, and that is 25. So multiply it. So A12 is equal to minus 25. So here 1, 3. For here 1, 3, because I'm explaining, so I have to take my time so that you understand it once. 5, 3, 5. So here as plus. So I have plus, then determinant of cover it horizontally, cover it vertically. So I have 3, minus 4, 5, 3. So this will be plus into brackets 3 multiplied by 3, 9, minus 5 multiplied by minus 4, minus 20. And this is what? Plus multiplied by 9, minus multiplied by minus 20, that is plus. So 9 plus 20, that is 29. So 29 multiplied by plus is equal to 29. Now here 1, 4 will be equal to, let's write it, 1, 2, 1, 3, minus 4, minus 2, 5, 3, 5. So here we have plus, minus, plus, minus. So here has minus, so we have minus here. So now cover it where it belongs vertically, we cover where it belongs horizontally. So you are left with 2, 1, 3, 5. So all these signs for this one, maybe we should cover clean it because we do not need them. We only need the sign of the element we are working on at that particular time. So A21, this is A21. A21 will now be equal to minus into brackets 10 minus 3. And that is what? Minus 7. So A22, here is A22, so let's write it 1, 2, 1, 3, minus 4, minus 2, 5, 3, 5. So here is A22 and it has minus. So I have minus, then determinant of cover where it belongs horizontally, cover where it belongs vertically. So I have 1, 1, 5, 5. So here 2, 2 will be equal to, multiply here, no, don't forget I have minus. So I have 1 multiplied by 5 is 5, minus 5 multiplied by 1 is 5. So this one is 0 multiplied by minus gives me 0. So here 2, 3 will be equal to 1, 2, 1, 3, minus 4, minus 2, 5, 3, 5. So this is A23. So it has, this is plus, minus, plus, minus, plus, minus. So this is plus. So plus, minus. So this one has minus. So I have minus, then cover it like this, cover it like this. So I have 1, 2, 5, 3. So this is minus. So 1 multiplied by 3, 3, minus 5 multiplied by 2, 10. So I have minus multiplied by minus 7. So this is 7. So here 3, 1. Here 3, 1. Here 3, 1. So let's write 1, 2, 1, 3, minus 4, minus 2, 5, 3, 5. You have to be careful, please. So here we have plus, minus, plus, minus, plus, minus, plus. So here has plus. Plus, so cover it like this, cover it like this. So I have 2, 1, minus 4, minus 2. So this will be plus into brackets. 2 multiplied by minus 2 is what? Minus 4. Minus 4, minus 4 multiplied by 1, minus 4. So this is what? Plus into brackets. Minus 4 plus 4, that is 0. So this also gives 0. So here 3, 2. Here 3, 2. For here 3, 2. So that will be minus. So the determinant, if I cover it like this, so let me write 1, 2, 1, 3, minus 4, minus 2, 5, 3, 5. Here is A32. So it has, this is plus, minus, plus, minus, plus, minus, plus, minus. Minus, so you cover it like this, you cover it like this. So we have 1, 1, 3, minus 2. So here 3, 2 is equal to minus into brackets. Minus 2, that is 1 multiplied by minus 2, then minus 3 multiplied by 1, 3. So A32 is equal to minus into brackets minus 2 minus 3, that is minus 5. So here 3, 2 is equal to 5. That is minus multiplied by minus 5. That's plus 5. So here 3, 3. That is the last element there. So 1, 2, 1, 3, minus 4, minus 2, 5, 3, 5. So here will be plus. So you cover it like this, you cover it like this. So A 3, 3 will be equal to plus. Then I have 1, 2, 3 minus 4. So here 3, 3 will be equal to plus into bracket. 1 multiplied by minus 4, minus 4. So minus 3 multiplied by 2, that is 6. So I have A 3, 3 to be equal to plus into bracket minus 10. So here 3, 3 is equal to minus 10. So what I need to do now is to put everything together. So put everything together. So let's put everything together. So I will now say that this is my cofactor of A. Let's use C to represent that. So the first one is minus 14, followed by minus 25, followed by 29, that is A 13, 29. A21 is minus 7. A22 is 0. A23 is 7. A31 is 0. A32 is 5. A33 is minus 10. So that is our cofactors of A. Now, after finding the cofactors of A, the next thing that we need to do is to find adjoints of A. Adjoints of A. And what is adjoint of a square matrix? The adjoint of a square matrix will be the transpose of the cofactors. That is, adjoint A will be C transpose. Transpose of C. So, and what do you understand by transpose? Transpose is when rows and columns of a given matrix are interchanged. So now, what I mean by that is that the first row of this cofactor becomes the first column of this adjoint of A. So we are arranging this horizontal vertically now. So minus 14, minus 25, then 29. So take another one, you arrange it also vertically here. So take this one, so you have 0, 5, and minus 10. So that is our adjoint of A. Now, our A inverse. A inverse will now be, I told you that formula for A inverse is equal to 1 over determinant of A multiplied by adjoint A. And our determinant of A we got minus 35 for it. So A inverse will now be equal to 1 over minus 35 multiplied by minus 14 minus 7, 0, minus 2, 5, 0, 5, 29, 7, minus 10. So the next thing that we need to find now is our x, because we have gotten the inverse of A. And recall that x is equal to inverse of A multiplied by B. So from here, our x will just be minus 1 over 35 minus 14 minus 7, 0, minus 25, 0, 5, 29, 7, minus 10. Then multiplied by b, and our b is 4, 2, minus 1. So x will now be equal to minus 1 over 35. So let's multiply this one. Minus 14 multiplied by 4. That is what? Minus 14 multiplied by 4. This is 16. 1. This is 4. Minus 56. So I have minus 56 here. Then minus 2 multiplied by 2 minus 7 multiplied by 2, sorry. Minus 7 multiplied by 2 gives me minus 14. And this is supposed to be plus before, so I have minus 14 here. 0 multiplied by minus 1 gives me 0, so plus 0. So this one also you multiply like this. So I have minus 25 multiplied by 4, that is minus 100. Minus 100. 0 multiplied by 2, so plus 0. 5 multiplied by minus 5, that is minus 1. So plus multiplied by minus 1 gives me minus 1. So let me write minus here directly also. Minus 14. So 29 multiplied by 4. 29 multiplied by 4, that is 36, 3, 8, 116. So that is 116. 7 multiplied by 2, so that is plus 14. Minus 10 multiplied by minus 1, that is plus 10. So my x will now be equal to minus 1 over 35. Minus 1 over 35. Minus 56 minus 14, that is minus 70. Minus, it's supposed to be minus 5. So minus 100 minus 5, that is minus 105. So 116 plus 14 plus 10, that is 140. 140. So I can say that my x is equal to, let's multiply my minus 1 over 35 by everything inside this column matrix. So I have minus 70 divided by minus 35. I have minus 1 over 5, minus 105 divided by minus 35. And I also have 140 divided by minus 35. So here, minus cancel minus, so this 70 divided by 35 is 2. Minus cancel minus. 105 divided by 35, that is 3. 140 divided by minus 35, that is minus 4. And you have to recall that our x, this capital X, is equal to x, y, z. So that means x is equal to 2, y is equal to 3, and z is equal to minus 4. So we have gotten all the 3 unknowns now, and they are the solution. They are the solution to this particular simultaneous equation. So please go through them. If you have any question for me, please leave it for me in the comment section. Till I see you in the next class. Bye bye.